Hello, my name is Jeremy Pollard. Today we will discuss a new nuclear technology known as small modular reactors, also referred to as SMRs. So, small modular reactors have a lot of interesting characteristics that make them a very attractive option for many applications. Explain to you what small modular reactors are, and I'll tell you about some of the future advantages, challenges, and future applications. So, let's get into this. First, we need to understand that small modular reactors are in fact nuclear reactors. They're just as their name implies. They're smaller in size and energy output than conventional nuclear reactors. And they're considered modular for two reasons. One, because they can be built off-site and transported to the nuclear plant site where they will be incorporated into the existing infrastructure. And two, they can start out as a singular small output reactor and be added to, almost like Lego blocks in the future if expansion is needed. So there are three basic levels of nuclear reactors. According to Coffee, there are microreactors, which operate from 1 megawatt up to 20 megawatts. There are small modular reactors, which operate from 20 megawatts up to 300 megawatts. And then there are your large scale conventional nuclear reactors, which are 300 plus megawatt. So microreactors are often referred to as VSMRs, or very small modular reactors. Microreactors that are around 1 megawatt are often called nuclear batteries. And these nuclear batteries are often used in remote communities where site conditions and power output needs don't support the need or allow for larger scale reactors to be built. Small modular reactors are generally defined as nuclear reactors with less than 300 megawatts of electric capacity. They're also smaller in size to traditional nuclear reactors, so they require a smaller footprint of land to be built on. Let's discuss the flexibility of deployment and scalability. The flexibility of small modular reactors is a key aspect of the impactful development of the systems. Their thermal output range is from 10 megawatts all the way up to 1,382 megawatts. The electrical power output range is 4 megawatts up to 300 megawatts. And the heat outlet temperature range is 300 degrees Celsius up to 750 degrees Celsius, which is approximately 1,382 degrees Fahrenheit. Some designs still in research and development phase seek to exceed 1,000 degrees Celsius. So that would be a very interesting advancement. SMRs typically have a 7 to 20 year core life compared to a 3 to 6 year lifespan of a conventional nuclear reactor. Their small size allows for replacement of the reactor itself versus completely rebuilding the reactor facility in a conventional setup. The flexibility in both output and the ability to replace the reactor make the small modular reactor a very attractive option for nuclear facility construction projects. Let's check out some charts. As you can see in the charts, they show that the breakdown of primary energy sources for the production of electricity. The far left chart shows the global usage, and the next three charts show the same information for the three countries, China, India, and the United States, which are your biggest consumers of energy. As you can see, India and China use a massive amount of coal, which is a major carbon dioxide producing fossil fuel. This is one of the reasons their air quality ranks among the worst on the planet. Let's do a little brief history of where nuclear reactors started out. In 1951, first nuclear reactor to produce electricity was built in Idaho. And the first nuclear reactor to be linked to an electrical grid was in Russia in 1954. And this reactor only had a maximum electric capacity of 5 megawatts, which is far below what we're capable of today. Currently, the most air polluted countries of the world rely heavily on fossil fuels, such as coal and natural gas, to power their electrical grids. And this high usage of fossil fuels leads to high concentration of greenhouse gas emissions, which lead to climate change issues. The application of more and more SMRs will help push these emissions down to help us eventually reach our goal of zero carbon emissions. Currently, we have a goal set for the year 2050, and hopefully, at the very least, SMRs are able to make some considerable headway towards this goal. Now, let's talk about the advantages of small modular reactors from a safety standpoint. Society, for the most part, still views nuclear reactors as an unsafe energy source. And this perception is one of the biggest hurdles for nuclear energy as a whole. SMRs are inherently safer than conventional nuclear reactors for several reasons. Uh, they acquire passive safety features that are built into the SMRs, which means no active response is needed in order to shut down the reactor if an issue arose. Also, the smaller output from SMRs as well as passive safety systems allow for much smaller emergency planning zones and a much smaller footprint for the overall plant. SMRs, all else being equal, they simply have less radioactive material on hand from conventional nuclear facilities, so a nuclear criticality situation is much less likely to occur. And if it does, it's going to be a much smaller window, much smaller area to have to build these zones. SMRs also produce less radioactive waste, which must be disposed of course. And less radioactive waste is inherently safer than more radioactive waste. SMRs also require less refueling than conventional reactors, and refueling can be done while the system is still operating. So that's a major advantage. With fewer refueling requirements, there's less risk for nuclear fuel accidents. Lower power also means lower operating pressure, which is definitely safer in the event of a leak or catastrophic failure. Greenhouse gas emissions from coal-fired power plants are an externality affecting the surrounding environments and overall human health. SMRs avoid the burning of fossil fuels, which eliminates greenhouse gas emissions, which is another fine example of an advantage we get from SMRs. Another set of advantages we're going to talk about are from an economics viewpoint. Small modular reactors offer a lower initial capital investment, greater scalability, and flexibility for locations unable to accommodate more traditional large-scale reactors. A smaller footprint allows for cheaper investment for both the land needed as well as the cost of building a larger plant. So the flexibility of SMRs allows for many options to plant designers, considering that the designs are standardized and simplified. The designers can start out very small with SMRs and add more pieces later to ramp up production as the demand increases. They can also be designed to be cooled using several different mediums. These include light water or other non-light water coolants such as gas, liquid metals, or even molten salt. Reduced emissions from SMRs greatly benefit from an economic standpoint. Lower emissions means less regulation penalties are incurred. Lower emissions also prevent health hazards, which must be addressed in the future. High-skilled jobs are created, which adds money to local economies. And lastly, SMRs also have a lower maintenance and operational costs when compared to much larger conventional nuclear reactors. Now let's talk about some environmental benefits. The most obvious environmental benefit that comes to mind is the lower greenhouse gas emissions, of course. Nuclear power plants do not use fossil fuels to heat their water, turn the turbines, so there's no burning of fossil fuels, which in turn creates no greenhouse gas emissions. Greenhouse gases cause all sorts of environmental issues, and if those can be eliminated, then the environment, as well as human health, will be improved significantly. Because of their lower energy outputs, SMRs are able to be paired up with energy grids of renewable energy sources such as hydro, solar, and wind energy, which all promote environmental health. And we all know that cleaner energy is just better for the environment in all aspects, and that's the way of the future. So what are some challenges and limitations of small modular reactors? We've discussed all the positives. Let's look at some of the negatives. Regulations, licensing, and political hurdles are common challenges with any nuclear power plant. This is going to be an even slower process when dealing with a new technology such as small modular reactors. All of the previous government regulations for nuclear reactors have to be followed, and with any new technology, they'll require a new set of regulations, which takes time to implement. The licensing process can already be slow, and with new technology, this process can be hindered even further. The same holds true for regulations. Anytime local and federal governments have their involvement with regulations for new technology, such as SMRs, there are many time-consuming hurdles that must be overcome before any construction may begin. Political hurdles can be an even bigger issue when talking about nuclear technologies. Needless to say, political parties tend to disagree on most anything, and this is definitely the case with nuclear energy. There can also be variations in regulations from one country to another, so a plan that works in the United States may not be feasible in the Middle East or Europe. There's also several economic, technical, and operational challenges with SMRs. We have to factor in the high cost of research and development. Anytime we try to implement a new, first of its kind technology, such as SMRs, extensive research and development must be done to assess issues such as safety, overall production expected, initial capital investment estimates, and construction timeframes. And sadly, oftentimes the actual cost to build nuclear technologies will far exceed the initial cost and construction estimates. These uncertainties slow the process of breaking ground even further due to investors needing reassured of a return on their investment, which is understandable. We also have technical maturity and reliability concerns. This is a brand new form of nuclear energy technology. There is no 25-year-old example of an SMR to be able to see the pros and cons in real-world scenario, to be able to ensure financial investors of success, and to improve on mistakes and shortcomings of previous models. Lastly, there are waste management and decommissioning issues. Radioactive waste and spent nuclear fuel, always a major concern of any nuclear plant. One advantage of SMRs is they are capable of using multiple different cooling mediums. Molten salt reactors actually help to get rid of some radioactive waste streams as the reactor operates. And molten salt reactors are designed to use less fuel and produce shorter-lived radioactive waste than other reactor types. Also, their operation can be altered for the efficient burnup of plutonium and minor actinides, which allows molten salt reactors to consume waste from other reactors, which is obviously a very attractive option. So, do we expect SMRs to play a role in global clean energy transition? Well, I've mentioned a few times that SMRs avoid using fossil fuels as an energy input for their reactors. And carbon penalties are expected to keep rising as global decarbonization goals and regulations tighten. So obviously, I believe SMRs appear to be included in future electricity production. Some countries that have never utilized nuclear energy are considering SMRs for deployment due to their advantages both economically and environmentally. Now, there are political barriers and pushback from certain groups that do not want nuclear energy as a competitor. But these countries have environmental emission policy demands that must be met, and SMRs help to accomplish such goals. The global role SMRs will play depends heavily on the cost. Current cost estimates are highly hypothetical, given the lack of SMR history to back these estimates. So these unknowns need to be scrutinized before SMRs can be deployed. So how do SMRs address energy needs in isolated regions? Well, the small size of micro and small modular reactors make them an attractive option for remote regions. The ability of small modular reactors to tie into existing power grids is a huge advantage. The design and size of modular reactors also makes them easily transported from site to site as needed. SMRs also help to enhance global energy security and reliability. Nuclear energy has been part of the planet's energy security for more than 60 years. The United Kingdom has recently announced that it will increase construction of nuclear power plants and also boost investment dollars into SMR deployment, which is very interesting to me. One of the reasons this move makes sense is because nuclear energy works together with renewable energy sources by supporting system reliability and security of a clean energy supply. This ability to seamlessly cohabitate with renewables is a great advantage. Imagine, let's say, a small island country that's invested in large amounts of solar and wind energy options. But sometimes there's not enough sunlight or wind power to keep up with the region's energy needs. Well, in this example, an SMR would be a great option to help support the island's energy security. When the wind's not blowing, the sun's not shining, the SMR just keeps on pumping out energy. So, to wrap things up, let's take a look at what we've learned. Despite the regulatory, licensing, and political challenges that would accompany any new energy technology, the economical, technical, and operational challenges are not insurmountable and do not outweigh the advantages and possible future applications of SMRs. Small modular reactors will facilitate access to nuclear energy in new sectors and regions that have previously been underserved. And they will replace the aging non-renewable energy sources and will complement renewable energy technologies. If you only take one piece of information away from this presentation that I've given, I would like it to be this. Decarbonization is the key to sustaining our environment, and small modular reactor technology is a pathway toward this end goal. So, here's a list of sources that are available if you'd like to perform some additional research. Uh, Thanks for your time and have a great day.